All right, we are here today for a 4coder Friday. As a reminder, 4coder itself, you can check out the pre-built version on itch.io. If you go to 4coder.net to find that. And you can also head over to the 4coder Discord to hang with the community. I am looking at today the community fork. And to keep just a reminder that this stream and all of my activities over at Mr. Forth Lab are funded by people like you who check out mrforth.com/membership. You can also become a subscriber on Twitch if you'd like to do that. But these are the perks you get if you go to mrforth.com/membership. And it's much appreciated if you do check that out and become one of those members keeping the lab open for the long haul. So for 4coder Friday, the first 3 weeks, I took a break last week, but the first 3 weeks I looked at the build system, I looked at the OS abstraction layer and the documentation system, and I looked at the config and project file system. So those are the things I've done so far. Today, I'm thinking we should look at language support. That's a big thing. I was just reading through. If we look here on major issues that I listed, Mac support's part of the operating system layer. Configuration parsers we just took a look at. The documentation system we took a look at. The build system we took a look at. The Lexer generator is one of the few things we haven't dived into yet, and that's a part of the language support in general. The other thing I didn't touch just there is this issue with the base layer. We've kind of looked at the base layer and the split custom layer, core layer in little pieces the whole way through. This is a big architecture design problem that is sort of the whole code base and not any one spot. So we've been seeing this in bits and pieces as we go, but we haven't touched the language support in 4coder at all. So that's what I want to focus on today. Patrick asks, sorry for asking, do you have any job or is this Twitch thing the thing? The Twitch is, in the sense that I'm streaming every day to raise awareness for what I'm doing. It's the thing. I'm not really counting on Twitch subscribers, but if you want to become a Twitch subscriber, I'd appreciate it. What I'd really love is for people to become members. This is what I'm counting on. The mrforth.com/membership is the thing. And if you take a look here, there's a lot more than just the Twitch stuff going on. You're becoming a part of my research projects in general. Okay, so let's look at some of the language supports stuff. So, interesting, BYP has an interesting comment that I'd like to respond to because I'm a little confused what you're talking about. It says the parser being non-incremental and blocking and assuming C++ is more the problem for Lang. So obviously, the fact that C++ is assumed is an obvious part of the problem, which I'm going to get into. But I thought it was incremental and non-blocking. I felt like I literally have background threads and the ability to do partial parses built in, don't I? I thought that, at least that was part of 4coder for ages. Maybe I ended up removing it. Oh, we're talking about the parser and the Lexer. Right. Okay. Yeah. So the Lexer is the first part of the language support, and that definitely got the attention that I was thinking of. The parser I forgot even existed. Yeah, okay. So let's see here. We're going to have to go look at custom. So some of the things that go into language support, there's the languages folder. So I have a 4coder C++ Lexer generator.cpp. LexGen main. So this creates a program. Oh yeah, this stuff is complicated. I thought I was clever when I did this. Whew, okay, this is a lot. So let's start mapping out the pieces we have as we go. Okay. Okay, so there's some handwritten code that hangs out like this. We're opening that for reading. We read the data out. We do that on both of these. Lexer CPP.h. So if I go over to generated, yeah, we find Lexer CPP.h. So that, okay, that's just weird and silly. So we have 4coder lexgen handwritten.h and .cpp. These are inputs to 4coder lexgen main.cpp, and they are sort of pasted into the generated files. That's silly. We don't need to do things that way. We could just generate the whatever this code is here that I thought I needed to couple into the generated code. Like, I don't need this to live with Lexer or cpp.h. That's not necessary. What should be happening here? These things should just be files that get included before Lexer generated files. Yeah, you can see first thing it generates that. Gen tokens. So that generates this enum of all the C++ tokens. with an accompanying string table. And then we have the CPP file. Okay. So there's the handwritten part. These must be the keywords. We have a table with 121 slots. And this table gets generated by the Lexer. Keywords dot first. Keyword set. So each keyword set. So this goes through the keyword set main keys. They go through the generator first. They get sort of laid out, like the hash table's already been optimized. I'm not sure exactly when that happens. I mean, for all I know, that could be happening right here. No, so this already has the keyword set defined. Someone else built the keyword set. You can see all of the types and functions are just crammed into one file, so I'm having a harder time exploring than I usually do because I can't see the list of function names. I could probably try this. Here we go. So declare my keys. That's how it all gets declared, but surely there's somewhere... Okay, key layout. There we go. Oh, there we go. So at the very beginning of gen keyword table, we finally optimized the key layout, and that's how we get the keyword layout right there. Okay, and then we're generating off of that. I see. Let's keep going. Base kind. Subkind. Okay. So these are strings. So this is a big string 8 table, defined in the most complicated way possible for some reason. I guess probably I'm trying to avoid string escaping by doing it this way. This is a great example of where generating code as a C file as for intermediate is kind of silly feeling. Okay, so there's a second table. That's why we have a list of these, presumably. And that's for the preprocessor directives. Yeah, the discussion happening with Terrace Python and BYP in about the Abner jump to error problem, that definitely is something funkier than just because it's from a project. Jump to next error should happen immediately the first time you try to, like, that should create the list the first time you try to create the error. Like, I mean, I don't have set up to build right now, do I? Yes, I do. Does this run the Lexer generator? No, it doesn't. If I were to change target. Like this. I used F1 there. It still creates the jumps when I hit next error. So something funky, there's something funky about that. Right, like, if I come over here and I kill the compilation, and I do it again, and I, like, click right here and press enter, that also works. Now, the fact that it doesn't just immediately parse these when they close feels to me like maybe a core issue that could have been solved, too. Like, there could probably be a hook that says, hey, this buffer, a process ended and it was outputting to this buffer or something. That could be possible. I don't know. So, carrying on with my notes here. So the generator apparently generates all of this from here down with this function. I don't know what I meant by contiguous control flow, Lexer. Okay, this is an old macro. This is basically the same as doing like DLL pushback in my current macro space, macro name system, but we're making this list of transitions. Right, there's this like set logic that I ended up doing. in order to push the optimizations far enough. And then there are actions that happen whenever you activate a transition. So what I'm doing here, I guess, is looking through a list of the transitions attached to each state. There's kind of like a shadowing thing that happens, I think, where if multiple states have the same transitions, then we want to default to the earlier one getting the transition. Maybe I'm encoding that directly. I can't remember. Maybe I can remember if I look at this. What is the input set and the field set? So the input set looks like a list of U16s. Interesting, not sure why that would be. A field set. Each list represents a set. I see, so we're creating a bunch of flags. And this is saying that this flag needs to have this value. So this is the set of all states the system can be in where this flag has this value. This is the intersection of those. So this is, in other words, we have one flag pinned to one value. Here we have multiple flags, each pinned to one value. And here we have multiple combinations of those where one of them needs to be true. I get it. And so what I called a condition node was just a set of inputs and a field set that could represent a combination state and input condition to a particular transition being triggered. That makes sense. All right, so kind of getting lost here in the lecture generator. I think the point is there's that. There's also the fact that if I look here, if we look at language support, the C++ lecture generator looks like this. So I kind of just declare a bunch of keywords and flags. And states. Yeah, so most of the generated files go into generated, but there are two separate generated folders depending on if you're talking about building the core or the custom layer. So there are two separate generated folders that it might be in. But if the generator it lives in the custom layer, like with the Lexer generator, then the generated code goes into the custom layer. And if the generator lives in the core, then the generated code goes in the core. Okay, so here we start building out the state machine by selecting a state. We directly handle an end of file case. We say any of these things at the beginning of an identifier. These things take us to a state called pre-L, pre-U, pre-U, pre-R. Then if error body is true or false, we have a different result. Error body or white space. So yeah, this is set up so you can kind of you're kind of constructing a state machine where the states, there's a discrete set of states here, plus there are these sort of flag-based states that proliferate more states. So being in the root state with this flag set to true is different than being in the root state with this flag set to false. So there's actually more states that are being handled by these conditional cases. But the point is, you kind of just script up what you think lexing your language is like from there, and hopefully it fits in a finite state machine. This is not the worst part ever. If I'm just like feeling it out, like if I had to figure out how I was going to describe a lexer to a generator, this wouldn't be a bad way to do it. It's a little nicer to write this than it is to write the handwritten lexer in some ways. I mean, debugging the handwritten lexer might be easier than debugging this for sure. But this is not a poor way. Like, this feels like it's a nicely controlled way to author a lexer. So maybe not the worst part of 4coder ever. At least not the interface to this. The lexer generator is still complicated. But, yeah, BYP points out something that I didn't bother to do, which is this is currently defined as a deterministic automaton, which means uh, basically by deterministic we don't mean that we're not talking about randomness. We're talking about at each step, the next step is clearly determined by the structure of the machine. Whereas in a non-deterministic machine, what you allow for is you allow for ambiguity. Some transitions, there are multiple options that might be allowed. And so it's non-deterministic in the sense that there are some states that you get into where multiple ways of proceeding are possible. And we're not saying we randomly pick one, we're saying we don't know how we pick one, but later more information comes in, and some of those things that were allowed might become in like dead ends, and other things that were allowed might become the only way to make progress. And there's actually an equivalence when you're dealing with like Turing machines or other types of automaton. This isn't necessarily true, but with finite states bases like you get in a discrete finite automaton that we're dealing with here, where you just have a list of states and transitions between them, it's possible to actually use non-determinism to structure to specify your structure and mechanically transform that into a deterministic machine. uh, they're equivalent compute models, so they're computationally equivalent. Computationally equivalent is the way to put it, which just is a fancy way of saying the things you can define with one can be defined with the other, and a simulator for one could be used to simulate the other, and so on and so on. Yeah, that's definitely true. This interface could be improved. I guess one thing I want to know from the people in chat who might have done this, has anyone ever used this lecture generator to write a lecture for a language other than the one that comes with 4coder? Has it been put to use as a lecture generator for other languages, and is it any good? Hmm. Now I remember RxI wrote this text editor called Light, which is like a C and Lua text editor. And somewhere in here, I thought there was some language parser definitions. Parser.h, parser.c. Here we go. So like if I want to use this editor with Lua support, the way they define it is yeah, they use a bunch of regular expressions, and they've got a couple of types: comment, string, number, keywords, operators, function, symbol, function. keywords, patterns. Hmm. Yeah, yeah. So I was just kind of curious. I'm taking a look at this to see because I know when I first saw this, I was curious to see like if maybe they came up with a much better way to do it. And regex might be useful for getting the Lexer up and running. It definitely has like similar stuff to what I did, except regex makes this really dense way of saying like here's a type of pattern for this type of symbol. Um, like this is the list of operators for this language. Oh, there is a C one. Yeah, this isn't complete, is it? Like it's missing. It's not very accurate. Okay, so they sacrifice a lot of accuracy to get there, which means it's not as much of a proof of concept that you could do a lot better, very simply. Um, I still do wonder if I don't know. Well, for the Lexer part, the reason the Lexer part got so much attention is for a long time I wasn't trying to do a code index, and so my main concern was just being able to get the token highlighting correct for Lexer relevant pieces. But let's actually go a step further here. Um, there's this thing called the code index, which is just this data structure, I guess. Um, and here's the CPP code. Again, it's not organized in a way that makes this easy for me to look at the whole structure. Yeah, I think I ultimately didn't end up liking my partially done code index, and I think other people have pushed the code index farther than I ever took it, um, in various like forks of the custom layer. But this just looks like it doesn't get used. There's just one global code index to the whole custom layer. It looks like in this system. Free list. Man, I didn't know anything about building data structures back then. Okay, so I have this nest thing, which contains a next pointer and a kind. Yeah, so this code here, let's talk about code index.h a little bit. This is kind of the beginning of understanding how you actually build data structures to create useful interfaces, right? This like it really has been since I wrote this that I became more and more familiar with how this works. Which makes this one of the oldest versions of this this is one of the oldest versions of this particular style I've ever written, and it's way, way, way behind how I would do it now. So I'm going to take a little time to talk about all the little problems. So first of all, needs a more efficient naming scheme and namespace. This code is too important to constantly be typing out index code underscore index underscore for every piece of it. Probably, if I were to do it again, I'd call this the index layer, something like that. Yeah. The construction interface should be outlined in the header. This is very important because when you come to use this data structure, the way you're using it usually is going to be to write a new language parser. And so you need to see a guide right away on how you actually start using this thing. And like, so for starters, it would be good to have all of the public functions listed out like this. Also, it'd be nice to know why there needs to be so many internal functions, but I'm going to skip over that part for now. Then there's the fact that it's like a global code index for the whole layer. I don't know which of these are really deserve to be public functions because it clearly wasn't thought through. Nest list, note list, okay. Let's take a look at those. Node. There's nest versus note. Next pointer, a kind, a range. This has text attached. This has a file attached. This has a parent nest. Yeah, these should have been Lego bricked. What they don't have in common is this contains children and this doesn't. But that's fine. This contains text and this doesn't, but that's fine. Yeah, they should just... I understand that they are set up to pair off with specific non-overlapping concepts, but they just don't need to be. It doesn't serve any purpose having them as separate types. In fact, how does a note know what nest it's inside of? It has a parent, but the nest can't find all of the notes that are contained within it, can it? Yikes. Yeah, so no one really thought through what capabilities this data structure should have. It seems pretty clear. Like, let's keep going, but I think it'll become more and more obvious. Stuff about the code index as a global concept again. Buffer, arena, what does that even mean? Code index set file. So we look up into the buffer to index file with that buffer ID. If we found a match, then we read that. That gives us our file storage pointer. So there's the storage for this buffer. Basically, we're associating additional information onto each buffer through this lookup table. That's what I'm understanding. Code index clear file. We clear out the arena that's already there. And then you're setting the arena in the index. So, okay. These are kind of like coupled. They're supposed to go together. So we're trying to set both of them. The index is the new data structure, and this is the arena that it lives on. So we're trying to get that memory. Our arenas here are being passed around in a funny way. I would make everything an arena pointer now, but back at this time I did not put the arena's current state, basically the thing that keeps track of how much of the arena has been filled and how much there, like where we are in the arena. The arena is a block of memory, and there's like a header part that keeps track of how much have we used and how much is left. And in this setup, that header part doesn't even live inside the same block. It lives outside as a struct pointing into the arena, whereas these days I have an arena pointer that points to the very beginning of the block, and the very beginning of the block contains those parameters so that I'm just passing around a pointer instead of structs. And the pointer to the arena is the pointer to the block, so there's just like sort of one concept instead of two throughout the system. We're doing pretty good. I'm gonna keep on making this change to the header file because I want to be able to just see what the code index actually looks like, and it's kind of hidden from me right now. But I'm gonna take a quick break, little 5-minute break here. Let's do this. Let's do this. So I'm gonna go take a 5-minute break and then pick this up. All right, I will be back shortly. Alright, so Terry's Python has an opinion, which is interesting. I generally think it would have been better to attach code indexes to the buffers, and then maybe some acceleration structure if you don't want to iterate buffers to look things up. Okay, so currently there's one global code index. And when you add notes to the code index, you say which buffer they go with. Well, is that true? It says here code index file. It looks to me that like that is what's happening. The code index file has the notes and the nests sorted per buffer, and we attach all of them at once on that buffer. That's what it looks like to me. And so I'm not sure how looking things up across the whole index works, but let's take a look. Code index list from string. Name hash table. Here it does look like we're looking into a global hash table with all of the names. So we hash the string and then look into the table to find the note list and then scan that. Yeah, I see what you're saying. It's still a separate data structure that's not synced up with the buffer across its lifetime. It's not like it's not in the managed scope of the buffer. Mm-hmm. 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 I can see why that would be better. Keeping the acceleration structure up to date is an interesting part of the problem that might have influenced the design decision. Or it might have just been a first pass at an idea that I think when I first started building this, it was Casey's idea, and I didn't entirely understand what we were doing, and it took me a while for this to click. And so I might not have been building it in an ideal way for a while there. Surely if you reopen a buffer that contains a note, it gets recalculated, because that's why there's this whole thing about setting the file, doing the clear on this. and then setting it, right? Like that should reset the whole file. Ugh, generic parser helper stuff. And then there's this very basic parser that I wrote, separate from everything else. This is not the code index, this is the CPP code index. So coming over here, so it looks like here it's visiting all the modified buffers. So presumably if we are clearing out things from dead buffers, it must be because dead buffers come through this and then get, you know, they get empty code indexes right here. That's the only thing that would make sense. Oh, man. The core doesn't even provide a way to track if a buffer is modified. Set buffer. Yeah, so we can see this right here is a sign of like what the real problem is with the adding language support to 4coder, is that lots of things everywhere are written to assume that you're either parsing a C++ or not. So do CPP parse. This is not generic language support, right? Generic language support would look like that, right? Similarly, this would be like, and so on and so on. Whoops, what was that? You go away. You stay. So here I have a hook that's going off whenever a buffer gets modified. And then you can see I'm not marking it as modified unless... So this global mark as modified set is actually more like the code index mark as modified. Like it's telling us which buffers are ready to undergo parsing. Right, so here right here, token lex full input C++. So again, there's nothing telling it how to, like, there's no other option but to parse at C++. Here, what it would need to be doing is figuring out which lexer to apply. Relex first. Like, how does that work? I don't even know, like, what is this for? I can't remember. Why is it C++ specific preprocessor body stuff? Same thing here. It's almost generic, but it's not. I see. So this is saying if it's a preprocessor, then if it's a preprocessor body token, then it's not actually in the root state of the lexer, and it needs to keep looking ahead. Yeah, this makes sense. Okay. It looks like it's shifting all of the nests, but it's not touching the notes at all. Why is that? Did code index shift never apply to notes? Kind of feels like notes should also be getting their shifts. Hey, there you go, Terrius. Code index erase file gets called when a buffer is ended. Erase file goes through and clears out whatever's in the storage and erases the index from the hash table and everything. Yeah, it seems like notes weren't ever really done. Puka, that's right. I go for the one space indent. It seems like the obvious solution. Right, if you are a tab indenter, then one of the things that is cool about being a tab indenter is that you only spend 1 byte encoding your indentation. But the problem is you never know how wide your tabs will appear on other people's screens. But spaces, well, we know how wide a space is, and 1 space can get the job done. And of course, I don't save my files as 1 space indents, although apparently this one's in bad shape for some reason. I save my files as 2 space indents when I turn off virtual whitespace, because I think that 1 space seems to blow people's minds a little too much, and then they can't even read their code. But when I turn on virtual whitespace, that's just for me, and I go to 1 space indents. Not sure, it says. Okay. Yeah, I have no idea what the deal is with the generic parser functions. Yeah, it just seems like an undisciplined mess, beginning to end. Index new note. So in theory, it does generate notes. I feel like designing a good code index. I feel like designing a good code index would be like if the code index data structure were good and were well structured, the whole rest of this could start to be figured out, right? I would just say, forget about the parsers I have, forget about the lexer. Let's start from scratch. Let's build a good code index. Let's build a good set of generic affordances that a text editor should have. So, like, we want to be able to color different types of keyword or different types of text for comments, keywords, literals, um, maybe preprocessor, and that might be it. That might be all I want to cover. Maybe I'll just throw in like functions, type definitions, um, that's about it. Something like that. Although I don't even know if I would need to add those. Then the next step would be to create the lexers that generate language-specific tokens and have a way to understand language-specific tokens as fulfilling a contract to the uh, expectations of the editor on how to mark up those ranges with those generic concepts, right? So there'd be this correspondence you'd have to set up for any given language. You'd have your CPP tokens, and they'd have some kind of CPP token kind, and there'd be some kind of CPP token kind to editor token kind, right? And so this is our parser, CPP parser. This is our CPP token kind. I don't know, editor from CPP, editor kind from CPP token kind, something like that. It's a long name, but you get the idea. And now, well, that's not, this isn't true. This isn't what the parser does. This is just something that exists. Parser would be string 8 to CPP to an array of CPP tokens and an index here. Something like that. Now, what I'm thinking of for a note, it would include a list of notes. So it would have children, it'd have a parent, like this. Let's see. Code index. What else did we have? So children, parent. There's gonna have to be some kind of a kind. Now, what were these is closed, open, and closed about? I think these were for helping to drive the layout stuff, right? It looks like none of these are marking it up as false, but that's the default. So these are all the cases where the range of a particular nested scope was a closed range. So we need to be able to ask any given note close equals blah 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 blah, open equals why are they marked as ranges? Oh, because we have two ranges. We have the beginning and end. Okay. How does this function work? It doesn't say. Maybe it's this way? Yeah. Yeah, that's what I thought. So you're setting your open to not be the whole token? Strange. Yeah, that's why I was confused, Terius, because it's like, I'm pretty sure I wouldn't have written this function name to be an I and I plus 1. There is a version which takes the token itself. That is true. And there are a couple spots where that's getting used. Like right here. But for some reason, I think I wanted to mark the range of like the open brace and the closed brace separately. Right, so I have these nests, and I mark a nest if it's closed or not, and then I give it an opening and closing range. And those ranges are the ranges for each token, but I don't actually use them that way, it looks like. It looks like I use them as integers the whole time. Okay, that's not what I'm doing here. Maybe there's a good reason to not do that. Let's see, if this is a preprocessor, then open and close are just points. But statement close is a semicolon. So these things are just like the ends of ranges that are not ended by a delimiter, right? It looks like there are some things like statements and preprocessors. And yeah, this is running off of generic parse, which is very C++ specific, actually. It doesn't touch the C++ specific tokens, but it's still C++ specific logic. So this should have just been rolled into the C++ parser. So the question is, do I have good reasons for marking the full range of a scope the way I do with two separate ranges, right? Do I want to mark the opening and closing as full ranges themselves sometimes? And I do save them that way, but I wonder if that's useful. I mean, one solution is to just say there's a single range inside of each of my notes, and to use two notes to mark them up whenever I have a range that has delimiters like that, right? Like, index note kind can be an enum that consists of a range, like a nest, and a delimiter open and a delimiter closed. So whenever I create a nest, that would have, like, you know, the nest for this range. The nest itself could go from this point here to this point here, and then that brace could be marked as as a delimiter open child, and that brace could be marked as a delimiter closed child. You know what I'm saying? And then I only need one range. On each note. So we'll have a little axiom here. For all of the C in the children of N, so if N is an index note, the range of C is a subset of the range of N, maybe? One of the questions here is, what can I do with this that is the editor generic, right? That is, if it's not language specific, how is it useful? Because probably sooner or later what I'm going to want is like lang kind or something, which would be like something like this, and then this would actually be recast. There'd be some kind of LCPP note kind or whatever. And so if you wanted to make C++ specific stuff like macros, comments, functions, types, you would put those here. And maybe just have the generic kind be like a definition or something. Right, this could look like All right, so we have children and parent. We need to be able to mark what file we're talking about. The code index file is how I do that right now. But why not just be able to say file goes to like a buffer ID or like buffer ID. For any given note, there's some buffer ID that we're talking about, right? We have location information with this range. We should also have location information via a buffer ID. All right, so still looking at nest. We've got this is closed is still an unanswered question. It feels like, I mean, yeah, might as well. It feels like that might be a layout thing, which might mean it wants to be associated with some kind of generic language-specific flag field, like, you know, lang flags, U32, something like that. And then let the language itself define how virtual whitespace. So in order to finish a language definition, one would need a parser that takes that to an array of tokens and an index note. This would be the root of the index note for this string. And then you would also need like a layout function, which would take this original string together with the index note and generate a layout. And it'd be nice if this could just be generic, which was part of why I was doing generic, but I'm not sure that that's realistic. I think it might have been better if layout had been just handed over to the language definer, right? Okay, so next there's this label that goes on a note, just like this. I guess we can let that just be a string because an empty string will work to mark something as not really being labeled. And I feel like I would also like to be able to mark things as tags. So what that would mean is I might be able to create a label and then give it children. Like if I have a definition for um, a function, then I would be able to mark it. And then if there was some way that I could say, for instance, take the word, just attach a documentation string as a search term for finding this, I might have that the documentation text put in as tags or something, right? I might be able to say like I want search terms, and then those could just be children. The problem with making them just children is then they would show up as their own matches, not as matches that point up to their parents, unless that's what tag means. If I type in a search term and I find a tag, then I iterate up through the list of parents looking for an index note that's not a tag in order to put it into the lister or something like that. An alternative would be to have something like tags be a list of string 8s, right? So then I could say there's a way to attach other search terms that point to the same note, but now every note has this list of string 8s on it. So that's why I was thinking maybe making it make each note thinner by having the children having children notes, right? We already have the ability to make a list of children. We already have the ability to attach a string to each child. We might want then the ability to say that something is a tag, and therefore these things will all be bogus, but its parent will tell you what you need to know. So then, this is what the main index note data structure looks like. But there's a couple of accelerators we want to be able to expect. And those include the ability to gather up all of the notes that are matched by some filter key string, right? I would also like the ability to give a buffer ID and a range on that buffer and get back a list of the index notes that are let's see, this would be notes from straight, notes from range, something like that. I don't know. I think that designing this something along these lines and then having the ability to add language definition after that, which is not the way 4coder got developed. The code index is one of the last things I added after having C++ parsing for years, which meant I didn't have any idea yet how I was going to define multiple languages, and I didn't fit the C++ parsing into that shape. And the C++ parsing just ended up sprawled all over the place with no clear distinction of like when I was relying on C++ specific ideas. I'd also like the ability to put in a buffer ID and get out the root note for that buffer. There should be up to one, at most one root note, or it might be unindexed. Oh, so many overloaded functions have to be written, don't they? Can't just pick one core function and call it the right way. You gotta adjust all the parameters in little tiny little itty bitty ways. You gotta make all the little bitty adjustments so that you can call it from any combination you want with no extra work. So that's the most important thing. So what is any of this even doing? I'm not sure yet. I actually can't remember what font I use on 4coder anymore. I wonder if it's still here. Yeah, it looks like it's running Liberation Mono. That doesn't contain the fonts. Yeah, those are the only two fonts I ship with. I think for a while I was using Hack, and I'm surprised to find out that I gave up on that, but yeah. Liberation Mono. With Inconsolata for the build panel. To distinguish it. Make it a little smaller. And then here's a command, toggle virtual white space. That just reaches into the config, the default config, and modifies enable virtual white space. Okay. So what are all these even doing? So this is C++ specific. Doesn't even try not to be. You can see right here. So yeah, this is just trying to guess at where there might be a good spot to wrap. And it scores points for a bunch of different things. It kind of works. Here I thought I would make the rest of this generic and just make this scoring function the part that is language specific. Interesting. I don't know about that. I mean, look, so layout does have a lot of complex work to do. I don't feel like I ever got super good at abstracting the layout stuff. Because like layout depends on things like, I mean, surely the font is in here somewhere too, right? Yeah, face. Left, right, top, bottom, layout vars. Get left, right, top, bottom, layout vars. What on earth? Who even knows? Advanced map, metrics, tab width. I don't know. Why is it called that? Left, right, top, bottom, layout? What was I thinking? Layout reflex? Get the layout reflex? How does that tell me what it's doing? Layout item list? I don't know. And like, where are these functions that just start with get? Layout rule. Ugh. So I think my idea was to move as much of the layout stuff from here over to another layout spot for reuse, but it's like not namespaced. So we're actually running headfirst into another set of challenges. The layout system is not well organized or designed. It is non-trivial to write a new layout function, but it is the layout helper code is not clearly namespaced or documented. Lots of hard text layout work is coupled with language specific layout work in the current layout function. So I don't know. That's a whole big problem. Probably needs to be thought through. I think that back when I was writing Virtual Whitespace, I was always kind of overwhelmed by it. Like, I knew it was possible, but it was just on the edge of what I was capable of. And so getting it to work was, like, all I could ask myself to do. Figuring out how I would organize it and make it sort of chopped up into clearly defined systems with boundaries that could be rearranged cleanly. None of that was on the table before. I think all of that could be done. There's no reason it couldn't be. But I think that this is a clear reason why C++ being built in was a choice that I made, because I was trying really hard to make virtual whitespace a thing. And that was more important to me than language genericness. And I never solved the problem so well that I could make it language generic and virtual whitespace at the same time. So I think that right there is one of the things that's like, if you really wanted to make 4coder a lot better at language support, you'd have to actually figure out what to do about virtual whitespace to a much better degree. Hi. Well, I stream as Mr. Forth. My name is Alan. You can, if you're new around here, you should go check out MrForth.com and see what I get up to. If you're gonna ask irrelevant questions, then I'll just mute you. Well, that's quite a lot of the language stuff that goes on in 4coder that is not great. We looked through the lexer, which is complicated. We talked about how, well, there's a couple things I haven't looked at yet. Isn't there there's stuff where it writes down, like it's trying to figure out what language, there's this is code thing. Where is treat as code? Right, so there's this hack here where I've specifically hard-coded in some extensions that are still right here in the code. And there's I don't even know why I wrote all this. Parse context ID. I think I was prepping for what I thought might be the future. And so instead of treat as code equals true, there's going to be a parse context. That's a relevant question. So do I do bare metal programming? I think different people mean different things by that. In the sense that I write C code, yes. I don't do embedded systems a whole lot, although I've dabbled with it. But I write pretty close to the metal. But this here means that if you want to start using, at least in the default system, the command map, if you want to start using the command map for code files, then you have to have it be one of these 5 extensions, because it's just hard-coded in like this. Alright. And that's even if, why is this like this? Even if you go string file extensions, oh, here's the extensions, parse extension line to extension list, treat as code string, treat as code. So we have a default config for treat as code. That is this thing over here. All right, so we grab this. We figure out, are we going to treat this thing as code by finding if the extension on this file is a match to one of these, and then we check it anyway. And I don't know why that is, but there's weird stuff like this all over the code. Right, it's just silly. And so you end up with the only output from all of that work being that you treat it as code, at least for this purpose, so that it can do things like code map and code wrapping and virtual indentation. Now, use Lexer also depends on this, so you're not going to be able to use the Lexer unless it hits that. Yeah, it's just like, that's just another busted piece. To answer your question, I enjoy low-level programming more, except that I think low-level programming tooling is not as good sometimes. Or at least it's not as good as it could be. It's not that high-level programming tooling is all that good either. They both have kind of crap 99% of the time. But high-level programming with good tooling beats low-level programming with bad tooling. But all things being held equal, low-level programming I prefer. Well, I don't know why that even exists. It seems silly. It seems like it should just be this, right? Maybe it's because I was expecting to get to here, but why would I even do this? Why wouldn't I have... I don't know. There's some questions here about, like, if we were going to start supporting multi-language stuff, how would a plugin declare a new language? Because this tells us how to... This language definition tells us how to work with a language, how to generate highlighting and, well, I mean, that is a thing too, right? So once we create this, we have new token types. We might start wanting to go like, okay, can we extend the color palette? And I actually don't know. I haven't done that. How does color palette extension feel right now? There's also like language definition. This is the kind of thing. A good language definition system would work like a modular plugin system. Just period, right? It is not as convenient to have to put it together in a mono custom layer system, right? Because we want to be able to say like, hey, I just am starting to work with HTML today. Can I get the HTML thing up and running like that? Not do I grab the headers and CPP files and put them in and put it into the chain manually and all that. Right, so BYP is saying color palette extension works great so long as they only use the custom themes that you provide. Somehow it feels like when you have a new language definition, there needs to be some kind of story, better story about color palette extension, so that new types of tokens that want to be added to the color palette can be done so reliably without breaking all the time. Right now, a user must switch to a finished color palette with the extended colors. No modularity story for color palettes. No transition story from old color palettes to extended palettes, etc., etc. Warp Pipe asks, are you continuing work on 4coder, or is this just for your personal build? Well, I'm not really working on 4coder or a personal build. I'm just taking notes and learning. I might turn all these notes into a series of projects for the 4coder community to work on to improve 4coder, but I also might just kind of use it as inspiration for other projects so as to not make similar mistakes in the future. I'm not really sure what I'll do with all of this right now. I was feeling a lot like, I mean, there's been some 4coder momentum happening lately. The community's been pretty active. Abner has been switching to 4coder on his streams, and I've just been feeling like it's been a good rest. I have a lot of people. Here's a big part of it. I have a lot of people tell me that when I publish 4coder and I put the notes on it about it not being a very good code base, or at least it having some pretty major problems that should not just be assumed that they're good. You should know that I actually think these are bad things about 4coder, and so don't copy them. And a lot of people think that I was too harsh in my note, and I don't think so. So I've been spending a lot of time digging in and pointing out all of this stuff that's still super busted in 4coder, just to kind of give people a fuller idea of like what it means to get to the end of a project and know that it has serious problems. And not to say that 4coder isn't useful for the people who love working on it, just that like these things didn't work out so great, and maybe I want to learn about why that is. Rhizoma, yeah, this is being archived. It's going to I have a YouTube channel. Here, I'll pull it up for you. If you type in Mr. Fourth Dimension, you'll find Mr. Fourth Programming, which is my main channel. But you'll also find this one with the little pumpkin 4coder hat. And all of my streams get archived here. So you can see everything I've ever streamed, at least in the last couple years. I try to upload here so you can check it out. Kind of low on coffee there. So there's a question, which is once we have a good definition of the parser and the layout for a language, how would we want the process of associating that to file extensions to work? It's my contention I would want that part to be config. So we would have some kind of new action that the core editor, or new action that either the core or the main framework, you know, the core, that the portion of the core editor that lives on the custom side, but some kind of centralized new action that would be like language register, where you'd give it a name and you'd give it the definition struct, and it would save that for you. And then you'd want some way when you create a plugin to automatically have new plugins be able to say like, hey, what are the things you are registering when you are loaded? And that code then goes with that plugin. And then finally you would have new config structure replacing treat as code. And this would be like, it would somehow need to be a extension map, which would map a list, which would map a file extension to a language name. So basically this would be a string map, right? I.e., like low level, we're talking about a string to a string. And so you might end up saying something like treat example. The syntax for this might be treat as code, would become maybe a compound instead of everything in config has always been a literal, but there's no reason we couldn't use the config parser that can handle compounds to go a little farther and say treat as code might start looking like cpp goes to the C++ language and HPP goes to the C++ language, and you know, we might just make a C++ parser and say like that's actually what we're supporting, and so the C and the H and the CC, right? All the different things we would treat as matching that. And then if someone came along and was like, hey, we made a JAI parser, you just put that in your config like that, and that would be how we do treat as code. Cool, thanks for dropping by. See you around. Young Lane asks me about GitHub etiquette, which I cannot answer. I don't know if you find a bug in someone else's code. I have occasionally sent in issues. I generally send in issues. A pull request is where you send in the changes to the code that you would make. And I never interact with pull requests. I don't really get them. I know that they're a thing. They're like a GitHub thing. Some people, lots of people are very familiar with them and use them. I just don't use it. I don't like other people modifying my code, and I don't like to tell other people how to change their code. I think that whoever owns the code should write all the changes to it because they need to know about those changes. They need to be intimately familiar with them. They can't just review them. I don't think that's good enough. I think if you own the code, you're the one who should write it. If you're a manager and it's your job to review people's code to keep tabs on what's happening, that's different. But whoever owns the code should write the changes. And if no one owns the code, then that's just a structural problem. So that's the way I view these things, and that's why I always just send in issues or do nothing if I find an issue. I send in an issue so that they can then write the change. And I've never been in an organization where I had to make pull requests so that other people could review my changes, and I don't necessarily like that. So BYP is suggesting that language changes should be hot reloadable, and I think that's a good idea, and that maybe they should be driven by a domain-specific language. And I think that's a good idea too. At least that's how I handled the Lexer part, right? If you look here, I made a domain-specific language essentially for the Lexer. That would be an interesting and possibly quite fruitful design space to spend some time researching, which is like make a plain text editor and then make a domain specific language for defining language support that is specifically, it is not for writing compilers, it is not for parser generators exactly or Lexer generators exactly, but it's for editor interaction. And make a language that defines how you're going to ingest text code and exgest or output the indexing and the highlighting for that code. And hopefully the domain-specific language would be designed in such a way that the domain-specific language would be designed in such a way that it could do things like incremental lexing and incremental parsing automatically from the domain-specific description, right? And so I'm curious what would your domain-specific language look like? Would it be a grammar? Would it be basically one of these things where you go like, okay, there's going to be like the root. We'll have the root is going to be made up of a list of definitions. Would it be one of these kinds of things? Or a definition can be, you know, a type or a function or a macro or a variable. But we also need to be able to put in comments. Like, would you do something like this? Would you do something more procedural, like a Lua scripting kind of thing, like parser if parse comment context comment equals, I don't know what your language would look like, but would it be like this? Like, I'm curious. Yeah, interesting. My main concern with things like this is it doesn't always let you control what the output side is going to look like. So if you use this by itself, you end up with an abstract syntax tree, you end up with what do they call a parse tree, which is this very verbose thing. But I have thought a lot about like BNF style stuff that could come with commands attached. So you'd have like, okay, as you're going, you might look like this. And then you'd be like, all right, well, what is going to happen here is that after we've detected a comment, we're going to say that's a note of a comment type. And this is going to be a note of a type. This is going to be a note of a function type. This is going to be a note of a macro type. This is going to be a note of a variable type, etc., right? And then, of course, you have things like a function, and you'd have function signature, body. And the reason you'd have that is function body might just be like, scope. Right? Maybe this would just be like scope. And scope would just be this, and scope contents. And then you'd have some way to say like all of this is going to get marked with a note called the scope type, and this will be a note delim open. This will be a note delim close. I thought about stuff like this. I feel like something like this could be possible. Yeah, you wouldn't want to do this for a full AST, but it would be good enough for an editor's index, like what 4coder has. Scope contents would be made up of, I don't know, ignorable and scopes or something like that. I'm not very good at writing BNF off the top of my head, but I think it would be cool if I could write, right? If I had all of this and I was like, open up, and I have this thing where I do Control O to open buffers and Control I to open buffers that are already open. It'd be cool if I could do like some kind of, control buffers, lister. What is it like? Lister, list all functions, all buffers, lister, buffer. What is the one that Control I goes to? Buffer, list all buffers, switch, is it open? Interactive switch buffer opens this up. Okay, weird names. I don't know if I like my names for commands anymore. I mean, they're very Emacs-y, strange. I would call them all listers now. But anyway, if we had a command that was like, boom, lister control buffer, right? Lister control buffers, and then that brings up something like this. But I could type in like, give me my language, C/C++, boom, and it opens up a buffer that it is tied to a file, but it's not just that it's tied to a file, it's also tied to a purpose in the editor, right? right? And it looks like this. And then I could see over here when I've got this open, I might have options attached like, oh, if this is the language buffer, then I might want to access the option to put this into developer mode. And then when it's in developer mode, I'll be able to see over here, not just the syntax highlighting, but like detailed information, all the notes in like a debug display of how this is getting parsed. And then I'd be able to say like, okay, what happens if, and then make some changes here and have this go through the editor's analysis. And if it's valid, see the change pop out over here. I've thought a lot about how to define this. I think this would be a really cool kind of text editor where there was some kind of built-in first-class idea of sometimes you have a text buffer and you want to write a parser for it, and so you want to be able to visualize your parsers working on a test text file as you are constructing the parser interactively. That would be a killer text editor. So just throwing it out there, if someone's looking for how to beat 4coder, there's a thought process that I think I would start with now, because I have all kinds of text files that I write down, just like taking notes on the fly, and then I wish I could parse them and use them as structured information like a week later. The question is, how good can this language get? Can it get good enough? That's the research question. Well, anyways, I've been streaming for a good long time today. We've made a lot of progress on the 4coder investigation process. I think I've made the case that the language support is pretty poor, and while I'm not convinced that the Lexer generator was a mistake, I don't know that that's where I would start. I put a lot of thought into that because I was worried about fast relexing and I wanted optimal relexing, and it turns out to be just a lot of code and a lot of time that went into it to still have really clunky language support for any other languages. So, yeah, I think a new 4coder that had better language support would probably need to start with a cleaner code index data structure and with a language definition before supporting any specific languages that looks something like this, and probably with a proper plugin system so that you could plug in multiple languages and have a config that understood, like, oh, if you have a C++ support plugin, then you'll be able to start seeing files parsed that way, but you need to map you need to configure for that better. And I think that's about the main stuff I would want to do differently to approach it and get a better result. That stretch goal that BYP brought up of having a language, a domain-specific language built into the editor, and then my own ideas of having like control buffers that the editor understands are significant because they control something like the definition of a language that is registered to the system. I think all of that could be really cool too. That would mean instead of plugins that something else is happening, is sort of, I don't know. It's interesting stuff, but something along those lines or farther than that would be nice to have. With that, I think we'll wrap up 4coder Friday for today. This has been our language support dive into the project. Again, 4coder.net will give you access to a downloadable version of 4coder, documentation for 4coder, and the 4coder community. 4cc over on GitHub 4coder community 4cc is the version I am working with that the community keeps up to date. And for MrForth.com/membership is where you can become a supporter or member of the Mr. Forth lab and keep these projects going. If you think that what I'm doing is cool and you'd like to see more of it, and if you can become a monthly or yearly contributor to the lab, that would be much appreciated. And with that, I'm going to sign off for today, and I'll see y'all around the internet. Bye.